CrateDB. So actually, CrateDB is the company behind CrateDB, and CrateDB is an open source distributed database. And so actually, it combines the SQL and search of standard relational databases, but in a distributed way, and it's really easy and simple to scale. So at CrateDB, I'm actually responsible for maintaining the CrateDB partner ecosystem, as well as building new SQL and database features for the database itself. What I really enjoy is working on .NET also, especially on .NET Core. And I'm really passionate about bringing Crate also to Windows users. Okay, so let's come to the agenda first. This is what I'm going to talk to you in the next approximately 45 minutes. First, I'm going to talk about CrateDB, orchestrated by Docker Swarm, and I will show you how you can use CrateDB in production afterwards. At the end, I will show you a demo of the best practices with Docker Swarm, orchestration, and also running Docker Swarm with a CrateDB cluster. This will actually include some really nice tips, tricks, and some useful practices. Yeah, let's move over and start with CrateDB and Docker Swarm, and also the clusters and shared nothing architecture that Crate also brings with. And yeah, one of these, we have here a great use case to actually that Crate really fits on, is this shared nothing architecture. On the left-hand side, you have a conventional setup. So in a conventional setup of an application, using actually a master-slave database, like for example, Postgres or SQL Server, the deployed stacks looks quite similar to this on the left-hand side here. And however, this given setup does not scale because all application servers use the same single entry point, and these applications, I use them for writes only. So you can only write on the master, but read on the slave. Yeah, and there you have this issue of a single point of failure. So actually, if this entry point here is broken, the complete stack is unavailable. So going with shared nothing architecture on the right here, it allows actually the DevOps to deploy their application in an, let me say, elastic manner without this single point of failure. The idea behind this is to extend the shared nothing architecture from the database to the application, which in most cases is already stateless. Yeah, and if you deploy an instance of Crate together with every application server, you will be able to dynamically scale up and down your database backend, depending on your needs. The application only needs to communicate to its bound Crate instance on localhost. So the application is here connected via Crate only on localhost, but Crate runs actually on each host. So the load balancer at the top here, it tracks the health of the hosts. And if either the application or the database on a single host fails, the complete host will taken out of the load balancing. So this is really a really nice use case of Crate. And this fits quite well with Docker Swarm. And actually the difference of Docker Swarm and Kubernetes, yeah, so Docker Swarm and Kubernetes and other orchestration tools are quite extremely important when it comes to running high available services in production also. So actually each of these tools generally has its own set of config files. So you need to author them in order to declare your services. So they are actually all a bit different in specific feature sets, but they all attempt to solve the same problem. It's about orchestrating container over clusters. So this is the main problem you have. So the big difference between Docker and Kubernetes is that Docker is not an external service. It's built in the Docker engine, and it will be shipped with Docker also. So this doesn't necessarily make it a performant tool. This really depends on your use case. But if you are new to orchestration, using Docker in Swarm mode, it may help you get started faster, as it uses the same commands and patterns you are already familiar with using Docker to run off the containers. So in my opinion, Docker is not the non plus ultra magical thing in some cases, but it can sometimes be quite frustrating because wrapping everything in a container can expose design and process flaws that might have been hidden before. Yeah, so just shortly about the Docker Swarm architecture. I'm sure a lot of you don't know this also, but let's get just through this quite quickly. So actually, the new features of Docker Swarm that have been introduced in 1.12 are scaling, multi-host networking, service discovery, load balancing, and rolling up the updates. This sounds quite interesting also for Crate. I will show you this in the demo. So actually the Swarm topology looks like this. You have manager nodes here. Usually in production, you can run from 3 to 5 manager nodes. This is quite common. And then you have here at the bottom the workers. So actually what the managers are doing is that the manager are doing all the decisions about how and where to run the containers. And they also hold the service specs. So it's also possible to add more manager nodes to avoid this single point of failures. And the data actually around for the data that can be distributed over these manager nodes is stored in a distributed service protocol. This is called Raft. Yeah, and actually workers down here, they are just responsible for running the containers, and they are just reporting their status back to the manager. Okay, let's look at CrateDB in production. And what is necessary actually to scale Crate in production? So there are a few things to consider. One of this is actually one container per host. So for performance reasons, we strongly recommend that you only run one container per host machine. There's also the persistent data directory. So actually Docker containers are ephemeral, meaning that Docker containers are expected to come and go. And any data inside them is lost when the container goes away. For this reason, it's required that you mount a persistent data directory on your host machine. You need to mount that into the /data directory inside the Crate container. And actually, currently, it's not allowed to run a second CrateDB instance using the same data path. So no CrateDB should use the same data path /data than the currently running on the same host. Though this is currently also prevented in the latest CrateDB version. What you should also do is using a custom configuration. So if you want to use this custom configuration, it is strongly recommended that you mount the configuration files as same as the persistent data directory on the host machine. inside to the container. So actually this ensures that your configuration isn't lost when the container goes away. Then we have also important thing is resource constraints. And this is really important because when you're running CrateDB inside Docker, the current versions of the JVM, the Java virtual machine actually is unable to detect that they are running inside the container. And as a result, the detected limits are wrong. So you explicitly must declare the heap size that Crate could use actually to ensure out of memory issues. Okay, so how does the multi-node setup of Crate works? So CrateDB is a distributed data store. And so in production, a cluster will typically consist of 3 or more nodes. CrateDB makes this cluster setup quite easy. And and it's quite easy to build up a cluster with a size that is really huge. And so you can add nodes as many as you want. Crate's designed shared nothing architecture is self-sufficient, and also all nodes in the cluster are equal. So how does the inter-node communication works? So you need to declare each hosts or the service names. You need to provide this as a setting when you start Crate. It's not a runtime setting. It needs to you need to restart Crate if you want to reset the setting. So do this on boot. So before booting Crate, you need to set these settings here. And also an important setting is the minimum master node selection. So setting this minimum master nodes here, this would avoid you split brain issues. A split brain issue is when you suddenly have network partitions. For example, here we have this we have this 3 nodes Crate cluster, and here we have suddenly network partitions in this cluster. And this node here, the gray node, is not available anymore. So what this setting is ensuring that the clusters who are reaching each other, they need to fulfill this setting, and they need to fulfill this requirement. So the green nodes, they are fulfilling the minimum master nodes requirement, and then they can build up a valid, stable cluster. However, this single node can't fulfill the minimum master settings, so it will be drained out of the cluster. So here are some references to manage Swarm directly on Docker Docs. We have also some best practices available on the CrateDB reference guides. And I will also show you in the next couple of minutes the zero downtime upgrade that is also quite interesting for production. Okay, let's come to our demo. For the demo, we use the official CrateDB Docker image. This Docker image is available on Docker Hub. It's in the official repository, as you see here, and the latest image is 2.0.6, which is currently stable. This image is built on and based on Alpine Linux 3.5 currently, and we host this also open source on crate/docker-crate on GitHub. There you would find the Docker file that we use. Okay, just shortly to our demo setup that I'm going to use for the demo now. So actually, I'm using an ingress network or overlay network in Docker Swarm. And the Swarm manager uses ingress load balancing thing to expose the services you want to make available externally in the swarm. So what the swarm manager can do is it can automatically assign the service a published port to the service. So you can specify actually every port you want. And the Ingress network has a really cool feature. It's called routing mesh, yes. And actually it makes it possible to query each of the nodes running in this Docker swarm. And if you, for example, we have here Docker manager nodes running, 2 of them, and 6 of worker nodes. And these 2 manager nodes are running Nginx to expose the running ports to the outside world. And if I query worker 6, for example, on port 4200, I'm getting into this into the Ingress network. There's a load balancer hosted on every node, and it says to me, okay, you want to serve a container exposing this port 4200, and it's delegating me automatically to the first Nginx that is exposing 4200. Yeah. And this would be for example, the Nginx running on Docker 02. And it's asking the swarm DNS that is automatically deployed on an Ingress network. It's asking the swarm DNS what it's going to query. So the Nginx has an upstream proxy in there, and the upstream proxy is, for example, my CrateWebinar cluster. It asks the DNS what are the hosts of CrateWebinar, and the DNS is delegating to a node in a cluster doing round-robin pinging. So it chooses a node from the workers and delegates the traffic to this node. So I will show you this now. So changing to the console, I'm currently in an SSH session on a Docker manager node. It's called Docker 01. So I can say Docker version. I'm running the latest version of Docker that is released in 2017 in June. So this is quite cool now. So I can say, okay, which are my nodes in the cluster? Which are my nodes in the cluster? And also which are my, Docker node ls. So these are currently the nodes in my swarm network. I have 6 worker nodes and 2 manager nodes for failover. Okay, so if I want to list my services that are currently running in my Ingress network called WebNet, it's currently 2 replicas of an Nginx and a visualizer tool. And I'm going to serve now this visualizer tool. So it's exposing on port 8080. It exposes a nice front-end interface. And this front-end interface shows me the current available nodes in the Docker swarm. They all have about 16 gigabytes of RAM, so more than enough for our use cases. And you see here the 2 containers. These are the Nginx containers. They are running on the manager nodes. And you have this visualization. This is the front-end container that exposing this nice front-end web web service here, and it's this container called Viz. So what I'm going to show you now is how to create a 3-node Crate cluster. So first, what do I need to create a 3-node cluster? I'm going to need a config. I've prepared here a config for a 3-node Crate cluster. The cluster name is called Webinar. It's available for all the hosts in the network. So I'm exposing to the loopback interface. I'm binding the crate to the loopback interface, using the data path /data. It expects me to have 3 nodes here in the cluster and 2 nodes till the recovery starts. And here we have the important feature, important setting, declaring the minimum master nodes. So it's actually needs to be half of the cluster size plus 1. So we have, when we are dividing 3 by 2, we have 1.5, and adding plus 1, we have 2. So we're declaring, say, minimum master nodes are 2. We are using, for service discovery, we can actually declare, this is also a nice feature that Docker Swarm exposes, we can declare the service name. So the name of the service can be the host entry when doing the discovery. I'm going to activate the enterprise license and ensure that that the minimum availability is set in the cluster. So I'm now going to create a config. This config will be stored in the Raft log. This is quite cool. So this config will be available over the Swarm. And we are going to create this config for 3 nodes, and we name it create 3 nodes. And we are going to use this config, the create3 YAML. Okay, it has been created. So I can show that when listing the config, I can say, okay, Docker inspect create3 Docker config inspect create 3 nodes. I see that the config is also stored encrypted. So I have here the encrypted hash of the config. So nothing will be exposed in plain text. So now I'm able to actually run a 3-node cluster. This is done by using this command line. This command in the command line. Actually, I'm naming the service same as the discovery, create webinar. I'm starting 3 nodes. The 3 nodes should appear only on worker nodes. So this is quite nice, this constraint. It will only ensure that the service is running only on the worker nodes randomly. It uses the webnet network. It uses a DNS, and it's doing it's routing and pinging over DNS round robin. Yeah, and defining the crate heap size is also necessary, as we heard before, setting the resource constraints, and also binding the data directory. This is done via this parameter here. I'm binding the host folder, the folder that appears on the host on the SSD 1, and I'm mounting it into this destination path called /data. Same for the config. I'm using this distributed configuration data stored in Raft. I can access it with this command line parameter and mounting it directly and binding it to the config path in the container. Yeah, currently I'm using the crate 203 image. This is not the latest. I'm going to execute it now. And I see Swarm has created 3 containers in the cluster randomly on 6 worker nodes. Okay, and now I can also use routing mesh to serve the containers. So actually, I can use the worker 6, for example. It runs actually nothing on its host, but the routing mesh guarantees that the traffic gets routed to the Nginx that is exposing the 4200 port, and this one is delegating the request directly to the running service hosts. So I can execute and serve the admin UI. This is nice front end of Crate, serving one of the 3 nodes in the cluster. So actually, currently I'm using the enterprise license. It's unlicensed. So this is why this cluster check, this critical cluster check appears here. So nothing to worry about. This is just about that I haven't licensed or configured the current cluster as an enterprise license, with an enterprise license. So I have here at the top, I see I have 3 nodes in the cluster. Can show this also on the sidebar here. 3 nodes forming a production setup, and I can also import data. So in this help here on the sidebar, I can import tweets. Yeah, and I'm redirected to Twitter, and I'm now firing Twitter ingests, Twitter tweets into the database. I can stop that, and it created me a table called tweets. I can query it using the console. Okay, that's nice. So there are currently, how many nodes? There are rows. There are currently 575 rows in the class rows in the cluster in the tweets table. Okay, so what I'm now going to do is a rolling update. So currently I'm not using the latest version, but I still want to have the cluster up and running during the rolling upgrade. So what I also want to do, I want to increase the amount of nodes in the cluster. So suddenly I see, okay, I have too much data in there. I have too much traffic, too many requests on this cluster are going on, for example. I need to increase the amount of nodes. So how do I do that? This is quite easy in Docker. So Docker service expose a nice command called Docker service update. It lets me define the configuration that needs to be removed, and also the configuration that needs to be added. So suddenly I recognize, okay, there's now currently create 6 nodes configuration available. I need to create it first. So I have the 6 node configuration here. So I'm going to increase to 6 nodes. That also increase the minimum master node setting. So if I say 6 divided by 2 is 3 plus 1 is 4. So 4 nodes need to be available to form the minimum master node selection. Okay, so I'm going to create this config to be stored in the Raft log. Create 6 nodes, and I'm using the create 6ml. Okay, nice, it's created now. So now I can use the this Docker service update command that I used before. So it's going to exchange the 3 nodes setting, 3 nodes config file that I used before, and it's going to add the create 6 nodes config that I've already created. It's also going to update to the latest version. I can use the --image parameter to upgrade the image. And I'm going to update and increment the number of replicas that I want to use. So I want to use a 6-node Crate cluster. Okay. Switching now to the visualizer. And it's now updating each container to the latest version. So it does it container by container. So it only updates one container and does then the other container and goes on and goes on. So you see that currently. So I think it had already updated the container because I've already fetched the latest image from Docker. It would that do too. Actually, I can serve again the CrateDB admin UI, and I see here, okay, I have 6 nodes now, running also the latest version of Crate. And what's really also is really nice, I have still my data there because using replicas. Okay, so this is quite nice. I'm going to remove this service now. This also quite easily, Docker service rm create webinar. It will remove the service. See that now here. So all nodes are gone. So what I'm now going to create is a zero downtime maintainability. So this is a quite common use case for running Crate in production. It's also really nice if you want to drain a node doing some maintenance on this node. So for example, if you want to increase the amount of memory on this node or exchange the hard disk or do whatever, but still you want to have a fully queryable cluster setup that the user even don't recognize that the cluster is down during the maintenance. So how do I do that? Again, I'm using the same command as before. I am going to create a service called webinar again, running all the containers one by one on each host. Should be one container on the worker nodes. This guarantees me that only one host gets one container. It has actually the same settings in there, uses the latest image. I'm going to fire up this cluster now. Looking at the visualizer. So Docker now starts the containers on the specific worker nodes. So 2 of them are now started, waiting for the other 4 nodes. Okay, yeah, now the 4 nodes are coming finally. Waiting for the admin UI. Probably refreshing. Yeah. Okay, nice. So we have a running 6 node CrateDB cluster, latest image. So let's fire up some queries during the maintainability. So for this, I'm going to create a table. I've prepared a schema for the table already. It's just a demo table called address. It has some fields in there, string fields, double, so floating point numbers, and also timestamp values. It actually uses three replicas. Okay, table has been created. Should appear now. Yeah, it appears. And what I'm now going to do is I'm going to fire fake data. You see that on here on the bottom. So I'm going to fire fake data into this cluster using the service name and the port and the table that I'm going to create, that I have created. I'm going to fire in 1 million records, and it uses a bulk size currently of 1,000. So each time a query gets fired into Crate, it has a content payload, a row payload of 1,000. Okay, now firing about, yeah, it's increasing to 5 requests per second. So I'm going to fire now data into this cluster. So you see already, it's firing into this table called address. It has already 110,000 records in there. So what I'm now going to do is I'm doing maintainability of one of the nodes. Okay, so Docker node exposes a really nice command to do that. So it's called Docker node update, and you can specify availability, a drain availability on a specific worker. So I want to drain now the worker 2, for example. Okay, executed it. So worker 2 is now completely gone, and I can do maintenance on this node if I want. Still, what does my ingest do? It's still ingesting records into the table. So it currently ingests more than 5,000 records per second. One request contains 1,000 rows, so 5 requests per second. So it's about 5,000 requests inserts per second. I can also drain another node if I want. Can drain worker 1. Still, I don't even recognize it that the node is gone. I am still ingesting data. Okay, so I see here both nodes are gone. So I will activate that now. I've completed the maintenance, for example. I am activating worker 2. Okay, I see worker 2 is coming up. Also look at the interface. It hasn't joined yet, but it will. Yeah, it has now joined. 5 nodes available. Okay. And after that, I have completed also maintenance for worker 1. So let's fire up this node again. Still, I don't even recognize this at the client side. Still firing in 5,000 records a second. Okay, I'm now currently at 870,000 records. Let's wait for completeness. Okay, let's do this nodes checks. That is currently occurred because their nodes getting down, so I need to refresh it so it does not appear anymore. So it has recognized that the node has disconnected from the cluster. So let's see. Yeah, the ingest has completed. 1 million records should be now inside the cluster. So when I do a select count star from address, I see I haven't lost any single record. So during this upgrade, every record, there was actually no data loss. No data loss has been occurred. Okay, so that's about the demo. Yeah, that was it. Thanks for watching.